Yeah, thank you, Anthony and Jeremy, for the invitation, and thank you, Barbara, for your first presentation. Hopefully, you'll find this one quite complementary to what Barbara just presented. So I'll just make a quick introduction, present some of the case studies we've been doing, raise some discussion points, and takeaways before the Q&A session that we all agreed was the most important part. So we want to leave time for it. For those who don't know us, so we called we're integral group, so it's a lot of different offices across the world. So Jeremy is from the Vancouver one, and I'm actually speaking from Paris today, and it's 9 p.m. here, and we had a really hot day. As MEP engineers, we've focused a lot on in the past on mitigating operational energy and then operational carbon, and we did quite a good job at it. But now it was time to get the full picture and to make sure that when we designing, we are actually designing it in a way that will effectively mitigate whole life carbon emissions, not just operational. Just before getting into the numbers, and apologies, the study is going to be, the presentation is going to be quite data heavy, but I'm sure it's okay for this presentation. I just wanted to approach this intuitively on how much of a problem it can be if we just start thinking about how much quantities it represents, like how much MEP elements we tend to put. And as Barbara said, we tend to be as we go over through very operational heavy in terms of very efficient systems, we tend to put a lot of different elements within our buildings, and these elements are mostly made of metals or type of plastics which are not the most carbon friendly, and it's also a type of element that has a really high replacement rates. So unlike structure or some facades, you actually have to make a lot of it. So at the end, really the embodied carbon impact really adds up. So different studies exist now to try to estimate the impact of embodied carbon of MEP. So I've listed a few, and I'm going to present our latest ones. We're going to see are a bit more spread out, but you can hopefully understand why they are more spread out. So we decided to look at retrofit and tenant improvement as a first step, and the idea was, so as Barbara said, having just even the right information in terms of quantities is enough of a challenge. So we decided, as building services engineers, to work from what we had, and BIM models happen to be, a great resources, and we decided to pick very detailed BIM models of buildings that were already built up, and really deconstructed them and we did a lot of dynamo scripting so we could extract the bill of quantities then that we use to match embodied carbon coefficients that, like for Barbara's studies, we really pull from a lot of different databases, and we use One Click a lot for this because One Click has the largest database in the world and is really pulling from all directions, and we're just looking at carbon. So that was our process. We tested it in 2018, 2019 with this case study that's been published in the SIPSI journal. So I invite you to have a look if you want to know more. I'm not going to go through the details of it. It was a study over 30 years, and we had the architecture part, and so we did the MEP, and you can see that we had actually, it was important for us as engineers to understand how much of an issue MEP could be in terms of embodied carbon compared to the rest. So it was a good response to us, like, okay, we actually need to look into this. You can see that the refrigerant part is quite spread out, and I will get back to it in terms of assumptions. But again, if you want to know more, I invite you to have a look at the study, and maybe I'll put a link into the conversation. What I would like to present you is new case studies we've been doing on office tenant improvement, but the idea was to look at different regions, so US, UK, and Canada, to see if we could learn something from it, if we could see some trends, if the hotspots were all the same. So these were the kind of questions we were asking ourselves. And this is what we got in terms of results. So we did it over 50 years. So really throughout the whole life cycle stages. We even included D, but it's not shown here. It's modules A to C. And you can see that the results again are really spread out, and I'm going to be explaining why it is, you know, it was interesting to see how different it was per region, and also obviously for a tenant improvement project, the scope of works are always going to be different. So that's why it's so spread out, and it was based on the assumption that is so it's over 50 years, but there's a 25 lease period, which is quite high when you think about it. At least in the UK or in Europe, the leasing period tends to be more 5 to 10 years. And also you have, you know, difference per regions. You can see that in the UK project, you didn't have a refrigerant, but because it's not included, it was included in the part before the tenant improvement. So there's also a regional difference. So I just want to raise several points and based on the study and discuss it with you. The first I would like to talk about is in use stage. So this is the graph just for one project, the Canadian one, where we're able to really break it up per modules. And you can see that the B4 to B5 is really important. We didn't have any data on B2 and B3, so that's why it's there is nothing. And it happened that for this project, the architects had done a life cycle assessment. And so we were able to compare what they had for their, you know, as architecture impact compared to the MEP. And the proportion of what we found was, you know, quite big. And it really means that, you know we need to retrofit our buildings, and we shouldn't really building new. So so that means that in that effort, building services engineers really need to be at the table, because MEP is going to have a massive impact in that process. And so it's just to add to my point here, just show the result in kilogram CO2 equivalent per meter square, where you can see the difference between upfront use, end of life, and recovery. And again, the use phase could be even much higher if you had a lower, you know, leasing period. And maybe we need to think about, you know, we tend to want to have, you know, shiny ceilings, shiny floors for each new leasing, and maybe that's not needed, you know, to scrap everything out and replace. So maybe we need to think about this. And even for this, we made some assumptions of a lot of things could be retained after a 25 lease period in terms of you know, plumbing or distribution. And oh, sorry, I didn't mention this is going to be published soon, so you're going to have all the assumptions listed, and it will be available on our website. Another point I would like to make, and again, Barbara talked about it, but is about the data and the data variance. So you can see, because we didn't have much data, we decided to use it all and to create this low, medium, and high impact scenarios, where we would be using, you know, lowest data for the low impact, highest data for the high impact scenario. And if it's just for refrigerant, that we would have different scenarios, but otherwise that's how they were created. And you can see that, again, that's the Canadian project. The difference is huge, and it can be a bit, you know, striking, and like wondering why so. But here I just put you some examples. In that case, this project was using water source heat pump, 10 kilowatt, And you can see that the data for generic data from Germany, from Okobodat, and generic data from France, there is a factor of 10 between the two. And and it's really hard actually to have visibility on why is that so different. Same for copper, you have massive, you have quite important difference. You could argue it's because of the grid factor, but the truth is that it's quite hard to know. But you just have to deal with it. But it's also, you need to be critical on the data you're using, and it's hard to be consistent. Ideally, you would like to use only one database, because it would be consistent within another, but it's hard to find everything in one place. So actually, we're working at the moment on a calculation methodology for MEP projects when no EPDs are available, because really, like, we're not going to say enough really EPDs as a standardized way of showing and calculating the data, and not just for embodied carbon, is really important and the way to go. But the truth is that EPDs are not always available, so we come up and working with SIPSI, and it's going to be published as a SIPSI technical memorandum in the next months. A conservative methodology to come up with figures based on few information from manufacturers to get some data and to create more robust libraries. And actually, we're going to be starting working with EC3 to create MEP baselines per product type. And it so happens that we're going to be working together with Barbara. I don't even know if you know Barbara, but it's been signed today. So that's exciting. And one other really important point I want to make, and we touched based on this with Barbara, is about refrigerant and how much of an impact it can be. So this one was so it's the US project, and we had a split system and a VIF system, and you can see that in the high impact scenario, it can almost be 30% of your embodied carbon impact, but which could be reduced to a lot less if you had low leakage rate and high recovery rate. So I put our assumptions below, and these assumptions come from like a full literature review and getting on contact with maintenance bodies to get some data. And that's another study we had done. I don't think I have time to talk about it, but on where we had looked at different heating generation equipment and comparing from a whole life point of view. And again, it's available online, so I can put a link.
Louise,
but on that note, yes. Sorry.
You've got 5 more minutes, so if you want
to
touch on
yeah,
it,
I'm all done. Oh, okay. I'll get back to it. But no, it's good that we have time for Q&A. Thank you. Sorry, I'm rushing. What I was going to say. Yeah, so the exciting thing is that all these kind of questions on the different studies where we saw that refrigerant was such an issue and that we actually could do something about it, we decided to really create a group and think about measures and best practice. So at first it was really something internal, and then we said, okay, we got to that point, what about we make it public and and we just share it, and if it can be used by other people, then that's great. So we've created this refrigerant best practice guide. It's going to be published in this month, where we really try to look at which lowest global potential refrigerants are available per the different systems. How can you mitigate leakage? How can you reduce the charge? How can you enhance recovery? All these different things. What could be the the selection process? And as Barbara said, cooling systems are really on the rise, and there's not much other options than refrigerant-based systems when it's mechanically cooled. So it's really critical that we need to address it. And if you need to use a refrigerant-based system, make sure you use it in the most optimized way in terms of environmental impact. So hopefully you'll find it interesting, and it will be available on our website. So when it's going to be released, and it will be published on issue. And I just wanted to make a very simple point of you can see that across the different projects, the data overall is very spread out, but it's also hard to compare because, you know, depending on the project, the tenant improvement scope is different. But it's true that the US, the American project didn't have much within its scope, and they didn't put much within the building. And that's, at the end of the day, it's the most effective way to reduce your embodied carbon impact. So I just wanted to put it there, and it's going to be linked also to your personal energy in a way. So that's just a point I would wanted to make. And also, there's a lot of things I didn't put here, but within the studies, we looked at trends, what were the hotspots, where were the biggest, element, the most impactful, where they all were the same. So we would be detailing all this as well. And if I had to take 3 kind of main takeaway, I would say on this idea that less is more, like really designing down equipment with still high efficiency, and with the idea of maybe designing out MEP systems is really an effective way to reduce embodied carbon. And again, Barbara said it, and I'm really supporting that idea, is that we tend to oversize our equipment, but really it's not used at this level. Designing for 95 percentile is really enough, and it's going to be reducing both your personal and your embodied, so it's kind of a win. And act on the other, easy wins. But refrigerant is a key thing. I don't know if you know, but Drawdown book, from Paul Hawken, refrigerant, leakage mitigation is the #1 thing you can do to cool down the planet. And actually, we have solutions, and we have way to go, and we can put pressure on the market. So we just should go for it. And when I say, and I think the last thing is what I said, transparency, but it's also about visibility, pushing manufacturers and even clients to request for EPDs, transparency, and long design life, and to make sure it's adaptable for reuse, or that there is like transparency and visibility on where it comes from and where it's going to happen. So I think the 3 important things. So merci, as we say here, and hopefully you found it interesting, and I think we can have some Q&A time.